The universe is an ever-expanding wonder, a boundless realm stretching really far from our comprehension. It is so vast that it remains problematic for astronomers and other scientists to determine its specific side. With the launch of the James Webb Space Telescope, however, much modern technological advancement has allowed us to look into the cosmos further compared with earlier times. Since the invention of the telescope, some medical findings have made space seem so big, pointing to an element about the nature of the universe. Famous scientists like Brian Cox, along with other astrophysicists, have shared some findings that have pressed on the outstanding size of our cosmos. In the observable universe, estimates propose there are around 2 trillion galaxies. It ranges within this estimate, mostly grounded on modern observations, although it is far broadly believed that this is only a small fraction of what can be an infinitely large area. Whether our observable universe represents a small portion of what could be an endlessly larger area is both astounding and a concept of humility. The universe is such that we are not only the remote observers of it but also, in most ways, an integral part of it. We are the universe, are turning into awareness of itself, comprehending its vast complexities through the lenses of technology and exploration. The James Webb Space Telescope has opened new doors for us to continue on a journey of unparalleled cosmic discovery. Traveling within our personal sun device offers a glimpse of the stunning scale of area. Imagine journeying at 70 miles per hour. At this pace, it'd take about 15 days to finish one lap around Earth's equator. Reaching the moon, a trifling 238,855 miles away, could take 5 months. If we set our attractions on Mars, the closest planet to Earth, the adventure could stretch an amazing 63 years at that identical pace. For Neptune, the most distant planet in our sun device, our experience could closing 4,400 years. These distances highlight the immensity of our solar machine, but whilst we look past our on-the-spot planetary buddies, the scale grows even extra incomprehensible. This is just how big space is. Voyager 1, while launched in 1977, remains a putting example. Traveling at a brilliant 38,000 miles per hour, it took Voyager 1 35 years to go out our solar system, subsequently getting into interstellar area in 2012. Even light, that can circle Earth 7 times in just 1 second, struggles to preserve pace with the significant distances of the solar gadget and past. Our solar system itself is but a small speck within the vast expanse of the Milky Way galaxy, a gigantic structure comprising about 300 billion stars. Each of those stars is apt to have its very own planetary contraption, similar to our Sun. Alpha Centauri, our closest stellar neighbor, is 4.3 light-years away. Even at the speed of mild, which is not possible for us, it would take over 4 years to reach it. At the speed of Voyager 1 to 38,000 mph, it would take the equivalent of a great 70,000 years to reach it. All this underlines the massive distances among stars and galaxies. As we widen our view to beyond the scale of our local community, the scale of space becomes truly mind-blowing. Vega, a bright star, is such an example, lying 64 light-years away from Earth. If one takes into consideration the radiosphere, the extent our radio signals have traveled within the past century, our messages have only been able to make it out to about 15,000 star systems. Even though that sounds like a considerable amount, it is but a small fraction compared to the 300 billion stars composing our galaxy. When we view Vega within the nighttime sky, we are absolutely seeing light that has left the star 64 years in the past. That means today the light we see has been en route since before many historical events even happened here on Earth. It is the grand scale of times and distances between stars that put our very own civilization's history into a much smaller perspective. To fathom just how vast the universe is, consider shrinking our entire solar device to the dimensions of 1/4. In this analogy, the Milky Way could stretch across the entire United States. The scale of this comparison is sort of not possible to fathom, and yet the Milky Way is only considered one of an estimated trillion galaxies within the observable universe. A trillion is inconceivably huge amount. To put this into scale, imagine gathering 1,000 clusters of 1,000 cats. You'd get 1 million cats. If you multiplied that by 1,000,000, you'll get a trillion, a number suggestive of the number of galaxies strewn across space. The Andromeda Galaxy, our nearest galactic neighbor, is 2.5 million light-years away, and is currently hurtling toward the Milky Way at great speed. In some billion years, the two galaxies will collide, but due to the fact that stars are so far apart, direct star-to-star collisions are not going to happen. This fact highlights another mind-boggling function of the universe's scale. Galaxies can merge and interact without their stars actually colliding. These cosmic collisions, while rare at the star level, may trigger the birth of stars, or even shape the galaxies themselves. Beyond our local cluster of galaxies, space expands further to reveal more clusters of galaxies. The Milky Way belongs to a small group of about 50 galaxies, the so-called local group, which is itself part of the Virgo cluster, containing over 1,500 galaxies in total. This gigantic cluster is at most classified as one of the many within the so-called Laniakea supercluster, an astounding 100,000 galaxies in total. We just happen to belong to a big supercluster. There are thousands and thousands of other superclusters that make up the observable universe. The more we reach our observations, the more galaxies come into view. Even so, this constitutes the tiniest fraction of the whole. Then there are immense cosmic voids in space full-scale regions in which account is scant. These voids can stretch across loads of hundreds of thousands of mild-years and appear as gaps between galaxy clusters. These empty areas feature considerably within the structure of the universe in what is described as the cosmic net, an interconnected network of galaxies, filaments of gasoline, dirt, and darkish remember that's held together by gravitational forces. Within this net-like structure, galaxies are clustered together to form superclusters of impossible size. Remember is distributed rather non-uniformly, and such systems underlie much information about the universe's evolution. Supernovae, black holes, and quasars add complexity to this grand cosmic landscape. Indeed, supernovae, representing the explosive death of huge stars, scatter the crucial elements to space, taking part in creating new stars and planets. In such explosions, the cosmos has been seeded with factors such as iron, carbon, and oxygen, key elements to life. With immense gravitational pull, black holes shape not only the curves of galaxies but can even launch powerful jets of electricity. Supermassive black holes at the centers of galaxies have an impact on the surrounding stars and gas, shaping the dynamics of complete galactic systems. Quasars are tremendously luminous sources, powered by supermassive black holes in active accretion. They can outshine whole galaxies and act as beacons, illuminating the universe as it was billions of years ago. Studies of quasars can provide astronomers with deeper insight into the processes governing galaxy formation in the distant past. With all the technological advances available to us today, so much remains a mystery. What does lie beyond the observable universe? With the expansion of space continuing, there are galaxies whose light will never reach us, placing them forever beyond our reach. The relentless stretching of space causes remote galaxies to recede at ever-growing speeds, pushing them past the limits of our detection. Some scientists estimate that the real length of the universe could be at least 250 times larger than what we can see, while others have suggested that it may indeed be boundless. The very thought of an infinite universe opens great philosophical and scientific questions, really challenging our knowledge of space, time, and life. With such vast distances and numbers, one can only imagine how minute we are in this big universe. Yet we are a small part of a very large, expanding universe, one well beyond our understanding. But we do keep our knowledge expanding with science and space travel to know answers to most fundamental questions of existence. The adventure through space is far from over. Knowledge opens with each new discovery to deeper knowledge, and our perception of the universe becomes greater with every passing moment. From tiniest to largest, everything in the universe invites us towards its secrets and welcomes the infinite quest for know-how.